Hello, we are into episode 124 today. And chemical engineering, any graduate today has several career options across industries ranging from fertilizers to pharmaceuticals to energy to petrochemistry, nuclear engineering, and many more. There are exciting routes to explore. Today, we have a veteran who's blazed his own trail. Shiv Shukla has worked in petrochemicals with BPCL. He's cut his teeth on massive refineries, and his experience has gone far beyond to designing and commissioning complex projects across countries in all continents in the world, building sulfuric acid plants, both big and small. He has built skills encompassing business development, and management, business analysis, solution formulation, process improvement, program management, the list goes on and on. It's a career which, he has touched on so many difficult and complex aspects. In this episode, he will speak about what it takes to build a career in chemical engineering, how a curious mind can take you so much further, and how problem solving skills ace everything else. And one of the things that he said when we had a conversation is that he found the best time to explore the refinery was when it was shut down for annual maintenance and he could walk into furnaces and pipes and see how the design and construction worked. For anyone who wants to pursue a career in chemical engineering, this episode is a must watch. My name is Venugopal Nair. I head Ideascape, a design and branding agency, and we do these career explorations every week, like we've been doing for the past 2 years now. So let me bring Shiv Shukla onto the episode. Welcome to the show, Shiv.
Good morning, Venu. This is indeed a pleasure to be on this show, and thank you for inviting me. So
Wonderful,
we
wonderful.
can
You
start
have
and have a good conversation. Yeah.
you've been into a field where, today engineers start with chemical engineering, they might do a stream, and then they instantly move to something else, or it could be IT, or it could be something else. So you have persisted. So if you could tell me about what your childhood was like and how did you get into engineering and how did you continue, we'll start from there.
Okay. I think, basically, I'll just give a brief background about myself. I mean, childhood, let's say I did my schooling in a village up to 10th standard. And then later on, I always had been dreaming about becoming an engineer. And obviously, those days, there was no particular kind of engineer which you wanted to be. And I did my 12th from Mumbai. And after my 12th, I did for a year, I was like trying to get into the IIT and the JEE, crack the JEE as they call it today.
Oh,
So I did appear for the JEE and I got admitted into chemical engineering. I
okay.
mean, those days, obviously, there were a lot of there were options. It was not just chemical, but there were other engineering field also. But somehow I landed up in engineering into the IIT BHU, and the one thing which enticed me into chemical engineering was the mathematics. My favorite
Okay.
subject has been mathematics, and I really loved it. So normally people think that chemical engineering means it's a lot of chemistry, but it's not so. We found during our college days that it's not just chemistry. You have to be more intuitive to learn the processes, and you have to be more intuitive to learn about the various mathematical tools, how to analyze the problem, how to solve it, and that's how we were taught all the design. So
Okay.
even sorry, yeah.
No,
So
I think I'm listening to you. I just
yeah,
yeah.
when we were about to graduate, those days, lot of my friends and colleagues and batchmates, they wanted to getting into the computers. Actually, I have been involved with the computers right from my college days, and we used to have those days punch cards and those kind of things. We didn't have
Mm,
the
right.
modern sophisticated computers. We used to have the mainframes,
Yeah.
but I stuck to my core. I never thought of getting out of chemical engineering, though a lot of our batchmates from other engineering branches, many people got into computers and the IT, which is later on nowadays being called as IT industry. Those days we used to call it
Right.
computer. And
Okay.
many of them, but my philosophy was always there that I have been trained and taught chemical engineering, and that is where I would develop my career. And I mean, computers are something which can be used in any field, so I will
Right.
use them extensively in my own core field. So that's
Okay.
how I
Okay.
stuck to the chemical engineering.
That's a
So
wonderful perspective, Shiv. So, what was your first job like? Once you finished chemical engineering, what were the options available to you, and what did you decide to take up?
well, during those days, we used to have IIT BHU. We used to have the campus interviews, and there used to be number of companies which used to come. But again, I got a job in those days in a steel plant, and I did go there. That was from the campus interview. That was kind
Okay.
of recruitment from the campus. But I was more interested being a chemical engineering to go into a refinery or a fertilizer company. So
Okay.
I started looking out for the jobs in the field of chemical engineering. And fortunately, those days we used to have these entrance exams to get into these refineries. And I got selected into the Bharat Petroleum Corporation, BPCL refinery, which was like earlier it used to be Burma Shell, and those days recently it had been converted to the government owned refinery. So it was really, I would say, fortunate to get into a refinery. And that's how I started my career as a chemical engineer in a refinery. Though I
So
had
tell
done
me
my
a
summer.
few things about your first days in the refinery. What were the kind of things that you learned early on? There must have been training for sure, but what were your initial impressions of working in this giant refinery and where were you?
Well,
Which refinery was this?
this was in Mahol, in Chembur, in Mumbai.
Okay.
So
Okay.
this is one of actually BPCL was a company which was very well known for its professional, let's say, atmosphere. In spite of even being a public sector organization, a lot of my colleagues and friends would say, "Why join a public sector company?" But we found that Bharat Petroleum, the BPCL refinery, was really a dream come true for a chemical engineer. And initially I was there for a year as a trainee. So first initial year you are posted as a trainee, and then after that you are given the appointment into, you kind of posted into a unit where you manage the entire operations of that unit. So first year we got the training in all the units, basically like crude distillation unit, and then catalytic cracking unit, and aromatics unit. So all the refinery units, we had a privilege, I would say, to be rotated through all the units and learn about the operations. And it was so amazing, so fascinating, that being from the college, we did not have practical experience. I mean, we had seen limited ideas. So I remember that even on the first day when we, as a trainee, after initial introduction phase, we were sent into the plant. So some of the supervisors and the seniors who were kind of supervising our training program, then they asked us that what are you seeing in the refinery and what are you seeing? One thing which we noticed was like these control walls. Some were painted in red and some were painted in green. And we were wondering, why is this? Why can't there be a simple one single color? So we thought there must be some significance to it. So when we were being asked that how are you finding and what are the different observations, the first question was, why are some of the control walls red, why some are green? And then we were told, look, the control valves which are red, they are basically failed to close so that the flow will stop. And the control valves which are green are failed to open so that when the instrument error or any failure is there, they'll continue and the fluid flow will continue. So that is the kind of learning we started to get into a refinery. And I remember, we would be a group of there were 6 chemical engineers in that particular batch who were lucky to be selected from all over India. So there were 6 of us, and we were divided into 3 groups. 2 of us being into a group, and we would go around the unit in the common same this thing. We would carry a notebook and note down all the observations, all the pipelines. We would climb up the top of the distillation column and observe that where the reflux was going, where was the feed tray, why was the height so different. And also the best advantage which we got was during the refinery shutdown. There
Okay.
was annual shutdown of 2 units, and in normally what happens is that one unit of a refinery will be shut down once in a 2 years, or that kind of operating campaign. So we were lucky enough to saw two such turnarounds or shutdowns, as we call them. And it was amazing to get to know the kind of equipment, to know the distillation columns, to know what exactly was happening. We had only read about how a wall tray looks or how a sieve tray looks. But when we got into those equipment, it was like kind of eye opener. Small things like why the wear height is this much, why it is not this. So those kind of things we started to discuss, and we started to understand the significance of each and everything. And we were fortunate enough that we used to be able to get the drawings of all this equipment from the library. We get a fresh set of the printouts, those ammonia blueprints, still smelling ammonia. And we would take those drawings with us and enter inside an equipment. And there'll be three, four
Okay.
of us sitting down and discussing inside the distillation column that how the
Wow.
downcomer is going, how the gases are coming up. So that was kind of learning which we had. And I would say it was a dream come true for a chemical engineer. We had always heard that a fertilizer plant or a refinery is the best place to learn whatever you have understood and learned in the college. So there you practically see it and all the operations are happening. So we were very fortunate to undergo that. And I can tell you that that kind of a time period of 1 year learning, I mean, it was like we never later on got in the other jobs, because normally what happens, once you have been trained, you are supposed to know everything. So then you start, handling the problems, solving the issues, and coming out with solutions. So that 1 year
Okay.
period is like kind of etched in our memory like anything. And when I meet my
So
colleagues and we discuss,
give me an instance of a problem that you solved later. The basis of whatever you had done.
yeah,
Give me something that happened, let's say about 4 or 5 years into your job, and then you
let
were,
me
suddenly faced with a problem.
Yeah, so let me tell you or narrate incidents that how these things came to be utilized, whatever we saw, whatever we learned. See, normally when we enter the plant operations, it's like we are first hand learning how the various processes work, how
Right.
the various equipment function, and how everything is integrated together, and the whole production and manufacturing of chemicals is happening. Now, subsequently, what happens? A chemical engineer is not just an operator. I mean, he also has to design those plants. So normally what will happen once you are 4 or 5 years older, when you change your job and when you go to different job function, like normally, particularly you will go to technical services or process design. So what will happen is that then you'll have to design, let's say you'll be given a problem that, okay, you have to design a distillation column or you have to design a absorption tower. So now you have to correlate, that what you have seen in the field, what is the theory. So I'll tell you my own experience. So initial days I spent in working in shift and learning about the operations. And then there was a time when I thought that, okay, now I had kind of become saturated and I wanted to get into design. And that's where I changed my job and I went into inorganic chemicals. I started with the sulfuric acid. And I
Okay.
joined the company as a process engineer, where my job was to commission these plants and do the entire process design, like design of the heat exchanger, design of the towers. Now, generally in the chemical engineering, this thing, what happens is that you apply whatever you have seen in practice in one particular plant to other plants, and that's where your own imagination comes to. Like for example, we had learned about various type of the ways where the liquid can be distributed. Like
Right.
in a distillation column, you have the liquid coming at the top and then it has to be distributed to all the sides so that it covers the entire cross section. So those kind of designs, some of those designs we had not seen in the sulfuric acid industry. So when I joined and when I started implementing those ideas, so I would take the experience of those and I would refer to those old drawings and then develop something new, that how to do the number of holes calculation and the sizing of the header and everything. So that's
Okay.
how those things, kind of carried forward from learning in the field to the actual design of these equipment. And normally, when we would design, obviously, we are expected to go in the field and see it operating and running. So it's kind of a validation of what work you have done. So you learn first, you see something, then you carry forward with that idea and implement something else in another plant. Like in this case, like the distributed design, the type of the support for the tower packings. So those are the kind of things which we used to. I remember learning from one field and then applying into the
And then you
inorganic
applying
chemistry.
it later. So
Yeah,
a question here, which is basically that these are maybe not a petrochemical plant, but let's say a sulfuric acid plant. The
yeah,
product is actually highly corrosive. So,
yes.
what are the safety protocols that you have to implement to begin with? And how do you conduct trials early on? How is it stepped up, or how is that first commissioning done?
A very good question indeed. And I would also give some light on how we carried forward from the refinery and how these aspect, the safety aspect, differs. See, for a chemical engineer working in different industries, there are various requirement on the in terms of the safety and the hazards. So there are a couple of things which are done nowadays. Like for example, what we do is what we call is whenever the design phase of a plant, we do something called HAZOP study, which is hazardous operations study. Now
Okay,
we identify that what could be the hazard. Now, in the case of a refinery, a fire hazard is the most of the important
biggest
parameter,
problem. Yeah, yeah,
very big problem. So you have to avoid kind of any kind of a source of ignition or any kind of a problem which might create a fire. Now there the leakage of some fluid, some from the pump and all may not be so critical. As against that, in a sulfuric acid plant, what becomes is that the fire hazard is very limited. Sulfuric acid, something which will not catch fire. But if somebody falls down in a tank, it will dissolve the entire person and the
crazy.
accident can happen. So there's a lot of thrust, what we say in sulfuric acid industry, in terms of the materials what are used. So there are a lot of advanced materials which has to be used. And normally for example, when there are pipelines, so pipelines will not be all welded. There will be some flange connections. Now, typically in a refinery, the flange connections will be just exposed to the atmosphere. There will not be any covering. But in a sulfuric acid plant, you'll have a covering of, the FRP covering over and above that flange joint, so that if there is any kind of a leakage, even with a pinhole or a very small leakage because of the pressure or any material giving away, so all that leakages will be caught. So those are the kind of mindset how we look at it. Then we look at another very important parameter is that we have to avoid mixing of water and acid at any place. Like
Yes.
in a heat exchanger where we are cooling this acid with water. So we are very careful and we provide instruments like pH analyzer, which will monitor whether there is any kind of a leakage happening from the cell or the tubes, and intermixing happening and the water becoming acidic. So those are the kind of norms which are there implemented in sulfuric acid. And normally in any industry, similarly, like for example, in the pharmaceutical industry and some other places, there are highly toxicating, toxic gases which can be evolved. So we design kind of what are known as the vent scrubbers. Like in the sulfuric acid plant itself, there is a product called oleum, which is nothing but basically a mixture of liquid SO3 and sulfuric acid. Now, oleum has a tendency to create sulfur trioxide vapors. So normally what we'll have is we'll avoid and we'll have any vent which is connected to vessel, there'll be a downstream scrubber, like where a liquid sulfuric acid will be circulated and any gas escaping will be arrested there. Similarly, in the refinery, there are these flares. Anything which has to be thrown out into the atmosphere will not be thrown out like that. This will go to a flare header, and then flare header will have a flame at the top, and all the thing will be combusted. So that is the kind of
Thank
difference
you.
which is there across various industries.
you you have illuminated me on 2 points which we hear a lot about. I didn't know what a
Yeah.
scrubber meant, but you've explained perfectly how scrubbers actually meant to remove the hazardous thing, and the flare
Yeah.
which we see is actually again meant to be something which is thrown out. So let me come back to you, just discuss on whatever we've discussed so far, and
Yeah.
then come back to you for the next segment. You're
Sure.
listening. Yeah. uh,
Okay.
Okay, you're listening to the My First Job podcast. I'm with Shiv Shukla, who runs massive sulfuric acid plants and he's built them across the world. He's a chemical engineer and he's a veteran. In the first instance, the first segment, what we spoke about was how he qualified from IIT BHU and then got into a steel plant, but then found his true calling in the first refinery in BPCL, and how his curiosity at a point when the plant was shut down helped him to understand a whole lot of internal processes because he could actually walk into the equipment and figure out what was happening. He also speaks wonderfully about how maths is just as important if you're a chemical engineer as opposed to just knowing chemical processes, because there's a lot of calculation involved when you're designing and commissioning something. He spoke of what it means to build a sulfuric acid plant. He spoke about how hazardous problems are handled and what are the additional safeguards which are implemented. So, in the next segment, what I'll be talking to him will be about careers, what are the entry level salaries, and what are the options that people have when they choose a career in chemical engineering. So, Shiv, if you can tell us, where do people start today? A person who's just finished, let's say, a chemical engineering, degree, graduation, what can he or
Mhm.
she hope to start with, and where does it go from there?
Well, for a chemical engineering graduate, there are multiple options open in the field of chemical engineering. First of all, one has to be passionate about the chemical engineering itself, and then he
Right,
will find various opportunities. I'll give you, kind of the openings and the examples. So there are different type of roles where the chemical engineers are taken, and initially, obviously, everybody takes them as a trainee, and generally for a year or 2 year they'll be put on the training depending on the job role what they have been selected. So first of all, let's cover that what are the various roles which are available. The
so
roles
sorry,
for the
during
chemical.
training, what do you hope to get? What is the kind of salary level? Is it about 25, 30,000? What are the kind of
Yeah,
salaries that
I'll come to that as
oh,
I
you'll
speak
come to
about the
that?
various job
Sure.
these things.
Correct.
Normally, see what happens is that this particular aspect will also depend upon where he's getting employed and which company. A salary of around 30,000 per month is easily possible in places like the metros of our country, and any manufacturing job also something like 25,000, 30,000 is a very norm at the entry level. Some companies may be giving it may give higher value also, depending on the, obviously there are a couple of things which are involved, like for example if the candidate is extra bright and he has already shown and done something. Let's say for example if you do some training program, some project in your college days, and the company sees that it can be beneficial, then the company will give you higher. So normally the companies will hire you for a roles in particular areas like plant operations. So one is the major area is the plant operations, and actually I would say that a chemical engineer gets to learn maximum in plant operations. Then the second
Right.
area is that you can start as a design engineer in the companies where you get to start learning on the process design aspect. Then the third area where you will be involved is kind of the sales and the marketing of various chemicals and those things. Those jobs are also open for one. Then there are two more upcoming areas. Like one is that where you are involved in the projects. For example, where you learn about the project management and the activities like how the whole thing is managed. And the last but not the least, other area where people are taken is for the strategic, planning as executive assistant to the, somebody at the top level. So, for example, if somebody is the head of a chemical engineering and he needs two, three engineers, so there are those kind of roles. So normally, most of these roles at the entry level will offer you around 25 to 30K per month, and some refineries and fertilizer companies may offer you bigger. Normally, if you go into a refinery, probably they'll offer you something like about 50K. Refinery jobs are much better in terms of remuneration. Now, also what happens is that some companies have now started taking chemical engineers for the operation of these plants in two ways. One is that where you manage the entire plant, where you are as the unit head, where you are responsible for the performance of a particular plant, like say for example a sulfuric acid plant or maybe benzene manufacturing unit, where your responsibility is to make sure that the plant is operating for 24 hours and there are no breakdowns. If there are breakdowns, then you get it handled by your team. So normally in a operations job, which requires you to be field in the field also, you may find that okay, it's a bit of a kind of being in the field as well as being in an AC environment. But being in the field is where you learn the most. The other job, which is basically where these operations people get utilized, is in the control rooms. Normally, these control rooms are AC. You sit in an AC room and you have the variety of control panels and you
Dashboards
observe
and
and monitor those parameters and control the units.
right.
So that also is very interesting for a chemical engineer to learn and go. But normally, what I would advise is that one has to dirty their hands. Unless you know the nuts and bolts of the equipment, just being in the control room, you will not get that feel. At
You're
least
not
that is
going
the
to
way
get
I
the
have
feel.
done. Then
Okay.
there are companies like which are into design and engineering, like there are multiple consulting companies which are basically executing projects for the third parties and the outside of India projects within India. There is so much of new construction work and the project going on. So they will take these chemical engineers who will start working as a trainee. Basically, they'll be taken for the design purpose, where their role is to study a flow sheet, study and prepare documentation, various design documentation. Like they'll be responsible for under training, under somebody senior who will design the thing, and they'll have to just probably document and prepare the operating manuals, those kind of things. So they will be in the design engineering job. Then the other job I was telling, which is more like project management, where they'll be tracking, let's say, for example, various equipment, manufacturing, various, what are the orders which have been placed. So they'll be working as a project engineer or those kind of things. So these are the kind of, let's say, 4 or 5 jobs which a chemical engineer can get involved. And also there is these, some people are good in the terms of, human skills like sales, interacting with the others. So they also get involved into the sales and marketing. I mean, all these, there are very, very basic chemicals like sulfuric acid and fertilizers, but also there are very advanced chemical and what we call as specialty chemicals. And there you need the knowledge of chemical engineering, chemistry to even talk about the application of a particular chemical.
Right.
So a
Right.
lot of
Right.
engineers get into that, into the sales and marketing job also. So depending on one's
So
curiosity and aptitude, one can get into these.
any of these, great. I think
Yeah.
that covers a wide this thing. One of the questions that I want to ask is when it comes to field, which is the actual plant. Most of them are away from metros, so that is one area where people, especially youngsters today, when you said they don't want to get their hands dirty, but
Yeah.
it's one of those things where if you spend 2 or 3 years there, the amount of learning is phenomenal because you can. So, how is it that people who are living in those places in the first 3 years, what is life like at that point? Because you've gone through something like that and you know what it feels like.
Yeah, I mean, well, most of these chemical plants when I used to go as a commissioning engineer are in far-flung areas. But I would say what is happening is that almost every chemical manufacturing company is also becoming basically sensitized to this issue of the younger generation coming in and joining. So what these companies are doing, they are kind of providing the facilities for the youngsters. Like normally what will happen is that if it's a big plant, like say for example, there is this IFCO which manufactures fertilizers. It's a large fertilizer manufacturing company. So they are located in a faraway place. One of their units is in Kandla, one unit is in Paradeep. Now, what they try to do, they try to build up a kind of a colonial life. So they provide kind of hostels for the unmarried people, and even for the married employees who get married 2 3 years down the line. They provide kind of the facilities which will make them stick around. So one is that you get to learn a lot in the field. If you are in a plant, if you are dirtying your hands, that is the kind of learning cannot be substituted. It's just like for a surgeon, doing the actual surgery is much more
Yes.
important. That's what you practice than just reading about surgery in an AC room. So that's how it is for a chemical engineer, that you have to be in the field to know about these tricks. So I think initial couple of few years are, I would say, tricky, but most of the companies are trying to give them a kind of life. Like, for example, I know there are companies which will give you allowance and a day's leave to go to the nearest city, and they'll have transportation from the factory site to the city. Like in Paradeep, they provide facility for people to travel from Paradeep to Bhubaneswar. So one could go to Bhubaneswar, which has a lot of city life. They could go to public entertainment places, movies, malls, and all these. So
Eat out. Yeah,
companies are getting
exactly.
sensitized about it. And another thing I'll tell you, Venu, is what is happening is that the manufacturing itself has a problem of retaining the talent and attracting the talent. I mean,
Right.
not many people want to get into manufacturing. Most of the people want to get into the services or a soft skill job, what we call as. So people don't want to get into the manufacturing. So that is one reason. Now what is happening is that as a result of that, these manufacturing companies have started to give certain premium in terms of the inconvenience which these employees go through. So they are offering extra monetary incentive for these younger generation, and they are giving you the loans, etc., for the vehicles on a very easy installments and terms. So these are the kind of things which the industry itself has taken upon itself to do, because the nature of
Right.
industry in manufacturing is that it's very important to retain the young talent and to attract the brightest. Otherwise, nobody will go there. And now, see, another thing I'll tell you, that in any economy, manufacturing is the base, on which everything else survives. Like I did my MBA, so I learned a lot about those things also. Unless you have a base of manufacturing, your services sector is not going to grow. Just like for exports, you need a certain domestic base. It's well economically understood that for you to be able to provide to the other services or other sectors, you need to have certain base. So manufacturing is the one which provides that base, and definitely. And nowadays, not everybody expects you to. Most of the things have become automated. There's a lot of instrumentation and automation, so you don't need to spend time in the sun in the field. You can be in the
Right.
control room, but occasionally get
Right.
out in the field and get the job done.
And the other part which which I can infer from whatever you're telling me is that
Hmm.
this kind of foundation for your career is crucial because AI is not going to be able to come into those service areas. The manufacturing and everything else, you can probably automate. What has got automated is already providing conveniences. But for the person who's into this manufacturing job, that skill is something that will serve them long term. It is something that they can build for the next 30, 35, 40 years, because it's not as if these plants will not be required in future, because whatever they are built for is constantly replenishing economies, and you can't get away from manufacturing. You still have to make stuff, whether it's fertilizers or toys or cars or anything. You can't get away from that. So knowing that is such an important aspect of uh, getting ahead in your career. So let's now go to what your own experience has been. How did you get into uh, building or starting your commissioning of your own sulfuric acid plants? Was that the next step, or how did you get into that?
Well, basically, in my career, I started with the refinery and then in operations in the plant in the field. And I used to work in the shifts, managing the entire shift operation and making sure that the production happens and all the parameters are well within control, no pollution, nothing. So after that, I went into design, which was kind of a natural progression, which was into inorganic chemicals. So then I have been, I would say, broadly into the variety of chemical industry. Like chemicals and fertilizers is the area which I have been working into last so many years. Ever since I graduated, I have never left this field to get into anything else. So the natural progression has been that from a plant operations, I moved into designing, commissioning of the plant and designing. And then next, I started handling the projects as a project manager, as a customer service manager, and troubleshooting, all those. Then the next level was, once I knew the projects, then I started doing as a, selling these. I was the marketing head, and then I was made the CEO of the company in which is Monsanto. It was a joint venture of Monsanto, and it's a US company. So I was at
Yeah.
the global level, at the global board in that company, and then I was handling the entire gamut of operations, of the company, like right from process design, getting the projects erected, built, commissioned, getting the money from the clients, and managing the team. And I would tell you that one of the major challenges was to retain the people. And that's what I used to always discuss with my boss, that how do we make these things interesting. So we used to have, I mean, there are a lot of creative things which the chemical engineers themselves can do. Like, for example, developed some in-house softwares for the simulation of the sulfuric acid plant, for the design of these equipment. So those are the areas where the people can get in. So finally, I was then for about a decade, I was into the water business, into the water and solar power business. That was for a company called Goa, which was a world leader
Okay.
in the this solar power business. So for a decade, I was more. Then that was a time briefly when I was moved away from the hardcore engineering up to only the management and the strategic this thing, like coordinating with the ministry and working on the policies at the country level, not only in India but countries like Kuwait and UAE and lot of. I was handling a vast region, right from Southeast Asia right up to the Middle East. So from east to west, I was involved into these water industry and the solar industry. And then in 2016, basically there was a problem with the company, and then the company had to shut down. So they closed down the operations, and that was the time when I decided, and I thought at that senior level I was not going to get a job. You don't get a job as a CEO and president of the company in any other this thing. So then I started on
Right.
my own, and because I had built up a network and kept the relationship in this industry, in the fertilizer and the sulfuric acid industry, and people started calling me that you have the knowledge and we have this problem. So can you solve this? Can you come and attend to this? So that's how it happened that I took off some of my colleagues from that company which closed down. And then I started this company. And today we are having, I would say, projects within India and outside of India. Like biggest clients of ours are like IFCO, Coromandel, Paradeep
Wow.
Phosphates,
Okay.
all large fertilizer manufacturing companies in India, plus companies like there is a company called Indo Jordan in Jordan. Then there is a company called ICS in Senegal, which is part of the Indorama group. There is another company in Egypt. So these are all fertilizer manufacturing companies, and that's where we are providing our services to them. So that's how we
So
started.
you've built a global network of companies, people, processes. You, I mean,
And
it's amazing how you. I always thought of Monsanto as a company that was into seeds because that is the public-facing thing. I had no idea that they had
yes,
plants and you were. So when you were working with Monsanto, were you in the US or?
no, I have always, I have always been, see, for last 20, 21 years, my bosses have all been in foreign countries, but I have been always in India. I've been handling the
Okay,
Indian office basically, and we
okay,
used to serve entire world, I would say. I mean, in Monsanto, actually, before Monsanto started focusing on the seeds business, they were into the chemicals and they were very well known for these chemicals. and they started hiving off these chemical unit, and that's how we were sold to another company. They sold the chemical business to part of it to Apengoa for the projects business and the technology, and other part of the products was sold to DuPont. So there is a continuous turnover. I'll see. I mean, the companies get bought and sold in this. So I have seen, I have seen Indian owners, I have seen American owners, I have seen Spanish owners. So that's how it has been. And I can tell you one thing: all this would not have been possible if I had not stuck to my chemical engineering. I
Very
see my
true. Very
colleagues
true.
who went into IT, they are into, kind of similar kind of a job work with one company. But here I see that I became the CEO of the company in which I had started as a marketing head or as a process engineer. And I, became then the global head of a company like Abengoa when I was managing so many countries. So all this would not have been possible if I had not been sticking to my core of
Stuck
chemical
to
engineering. And all this while
wonderful.
I mean, I used to sell these power plants also in Abengoa, and all this chemical
Right.
engineering knowledge did help me there.
Right. Let me
So that's
just
how the journey
take a
has been.
small break here.
Yeah,
Uh,
sure.
I'm continuing my session with Shiv Shukla, and he's expanded wonderfully on the options that are available to people who are looking at an entry level job into chemical engineering. He talks of why it is important to get your hands dirty and go through the difficult aspects of manufacturing, because that gives you a foundation that you can leverage all your life, whether it's in processes or it's in design or it's in commissioning. And the wonderful part is that it's led him to build a network across the world. And he's had the chance to sort of build that network and leverage it to the point where he can do things entirely on his own, and his expertise is deeply prized. Going ahead in the last segment, I'll be speaking to him about how he sees this entire career play out and what are the lessons that people who are watching can take from this. If you liked what you've seen so far, please subscribe, share, and let people know, because our job, as at my first job, is to try and ensure that you get a deep insight into every profession and the professional. And we are speaking to veterans and people who have a great deal of on ground experience. So, Shiv, in the segment yesterday, I think you had told me that sulfuric acid, one of the main uses of sulfuric acid, is into fertilizer plants. So, give me some instances of how you built the business and what are the challenges and possibilities.
Yeah, let me start with this. Many people would have studied or heard that barometer of an industry in any country is the sulfuric acid. So
Okay.
even if you look up at the website of the Chemical Engineering Association or the Institute of Chemistry, like internationally in the US and other, this is one of the molecules which is produced in the maximum quantities. This far exceeds any other molecule being produced in the world. And predominantly sulfuric acid, I would say about almost about 85 to 90% of it goes into manufacturing of fertilizers. See,
Okay.
when we talk about fertilizers, there are basically two kind of fertilizers. One is the nitrogen based, nitrogenous, and the other side is the phosphatic industry, phosphatic based fertilizer, phosphate based fertilizers. So sulfuric acid comes into the picture in the phosphatic side of the fertilizers. See, phosphatic fertilizers are basically made by using phosphoric acid and ammonia, both which are chemical molecules. And this phosphoric acid itself is made by using sulfuric acid. Sulfuric acid is one important raw material for manufacturing of phosphoric acid. And all our bones are containing phosphorus. Will not have, and the plants need this phosphorus to grow. And all this comes through the phosphatic fertilizers. And without sulfuric acid, you cannot extract this phosphorus from the rock phosphate. Rock phosphate is basically the one which is the raw material which is mined. There are mines in
Okay.
world where you get this rock phosphate. To extract that, you need sulfuric acid. So that's how sulfuric acid is coming into the play, and bulk of it is used in the fertilizer sector. And some other important aspects of uses of sulfuric acid are, like, for example, not many people may be aware, but even your artificial intelligence machines, all these electronic chips, they need sulfuric acid for the cleaning. There we provide, and build plant which is called as the ultra pure sulfuric acid quality sulfuric acid product, and all your AI, the batteries, and nowadays, in fact, major usage of this sulfuric acid going into be for lithium extraction. Nowadays almost everything is like electric vehicles. So many gadgets we are using which have these batteries, and all these use nickel or lithium. So also a bulk of sulfuric acid is also used manufacturing nickel as well as extraction of the lithium. So in fact, I would say that in the future, there are some projects being planned for the lithium manufacturing and these alkaline battery manufacturing based on the lithium phosphate, which is sulfuric acid based process. So basically, first of all, the worldwide needs of sulfuric acid are never going to grow. The population is continuously growing. Fertilizers will be required, food grains will be
Right.
required. So sulfuric acid will be required for all these basic needs. Sorry, not only for the basic needs, even for the advanced computations and all these work what we do, sulfuric acid is a very basic molecule which is used. So that's how the sulfuric acid is predominantly, kind of there in our lives without us even realizing it. The
Okay.
cereal which we
Okay.
ate today or the cold drink which we consume, it has phosphoric acid. That phosphoric acid has been manufactured by using this sulfuric acid. This
Well,
watch which we wear and the nickel which goes in there, it has been extracted with the sulfuric acid. So that's
okay.
the kind
Okay.
of this sulfuric acid plays. And obviously, all these are for the chemical engineers. I mean, these are the people who are chemical engineers who are doing and developing these processes and everything.
So when you go into commission a plant for sulfuric acid, or
Yeah.
what are the kind of things that you're looking for to begin with? What is your first step, and how does the plant come into being?
Okay. Basically, our company provides services, in the each and every area of the sulfuric acid plant design, troubleshooting, monitoring, commissioning, everything. So normally, obviously, any project will start with the conceptualization and the construction. When the plant is ready, then what we do is each and every part of the equipment have to be tested. Like there will be reactors, there will be towers, there will be equipment like pumps, compressors. So what is done is that every equipment is tested, and this is called as the pre-commissioning phase before the plant is started up. In the pre-commissioning phase, for example, there are storage vessels, there are these towers. So now what we'll do is we'll fill up these towers and pressure test them. We'll fill up these storage vessels with the water and test them for the leakage. So all the equipment similarly will connect the electrical motors with the pumps and run the pump and see that the direction of rotation is appropriate, the pump is running, there is no loose connection anywhere. So all such testing is done. So that's called the pre-commissioning stage. Once we have done the pre-commissioning stage, that means there are no more, kind of surprises which will be coming up. So the plant is ready for the next step, which is the actual startup. So normally in a sulfuric acid plant startup, what happens is that we have to take up, it's a procedure, we have to take up for about 24 to 48 hours to prepare the plant. It's just like before start any engine, you used to crank it, right?
Yeah.
So similarly, in a sulfuric acid plant, we heat up the reactor beds by burning fuel in a furnace and taking out the exhaust gases. And at the same time, all this air which is provided for burning of these gases is dried by using the sulfuric acid itself. So like
Oh,
that is the first phase, that we heat up the entire catalyst so that the catalyst will start reacting. So that is one part. Simultaneously, another part is the raw material. So sulfuric acid is manufactured using sulfur, And sulfur comes into as two forms. Either it comes as a solid sulfur, or wherever the plants are close to the refinery, so there will be molten sulfur. So molten sulfur will come through the tankers and that'll get directly used. So in the plants where there is solid sulfur, so the first part is that you have to keep the solid sulfur ready and convert that to the liquid sulfur. So there is a equipment what we call a sulfur melter. So basically you melt the sulfur and then you make that. So now once you have your sulfur ready, you have your catalyst beds heated up, then you start pumping this sulfur into the furnace to burn it. And then you burn this sulfur and you produce gases. And those are called SO2 bearing gases. Then those are sent into this reactor where you'll have sulfur trioxide formation. Then this sulfur trioxide will go to another section of the towers where this will be absorbed in the sulfuric acid, and that is where you will get your product from. And there will
So
be a lot of
typically, how long does it take to build a sulfuric acid plant?
uh, generally, let's say a lead time for a large sulfuric acid project is anything from about say something like 24 to 30 months is the lead time
Two
for
and a
the
half to
entire
3 years.
project.
Okay.
Out of that, I would say about also the most of the things go in parallel. Like the design will start, ordering will start. So design process itself takes about 6 to 8 months. Then the plant construction itself takes about 12 to 14 months. So about 12 to 14 months is the plant construction time, then hookup time and everything. So normally the commissioning of the plant will take about 2 weeks to 3 weeks. With in between that, 1 week is for heating up the plant, and then another 1 week for you to get a drop of sulfuric acid being produced. And that's the most exciting moment for us, Okay, now the sulfuric acid has started to flow,
That's ready
and
and
the
it's
project
online.
owner will
So
be very
you
happy.
so you've seen a lot
So,
of this during your career, Shiv. So what in kind of closing, I want to understand what is your advice to people who are currently doing chemical engineering, how they should go about figuring out what they need to do and what is the best way forward?
okay. Answer to this question is obviously different for different individuals, and each has to decide on their own this thing. The
Right.
first and foremost is deciding that you want to pursue chemical engineering. If you once you have
Yeah.
decided that step and taken that decision, the rest of the things are all simple. So the first step is that you decide that okay, I have learned chemical engineering in the engineering college. I'm not going to get into the IT or selling coke or selling the sugary drinks or selling soaps, or I don't want to get into the stock market and finance. So once you decide that you want to pursue chemical engineering, and I think
Yeah.
people who love this will enjoy it. So once you have decided that, then the next step is that try to approach the companies. And there are companies who recruit you as a graduate engineer trainee, as engineer trainee. And as I told that there are plant operation related jobs, there are design engineering related jobs, there are project related jobs, there are sales jobs. So anybody who wants to excel and probably be an example in his field should start by learning and dirtying his hands. They should not be scared about discomforts. Don't worry about being in the, let's say, out in the field in a plant, and it may be smelly, it may not be a nice AC room, but that's where you learn. Most of us learn, I mean, when we are in this world, I mean,
Very
we have
true.
to bear all kind of situations. So they
Right.
should be ready to initially do hard work for at least about 4 to 5 years. After that, the things become more easier. And I would
Comfortable. Yeah.
also say that the people who work, they should work in the shifts, basically where you learn the teamwork, that how plant operations are happening and how the teamwork is done and how you achieve your targets with a common objective of manufacturing something. And then try to get into, whenever you get an opportunity, be inquisitive. Try to ask, why this way, why not any other way, why is this rotating in this direction, why it is not rotating in another direction, and what will happen. So question why, what, be inquisitive, and the learning will automatically come to you. So you dirty your hands, to summarize, you dirty your hands, start learning from the first principles, and whatever you have learned in the engineering college, apply those to understand what is happening. Let's say if a reaction is going on, try to understand, and try to learn about all those things you have learned in thermodynamics, in the chemical engineering, kinetics. Try to apply what kind of reaction this is. It's just like a doctor who has understood and learned about the diseases. By the symptoms, he tries to see what are the symptoms and how do you
See
identify.
what happens. Yeah, very true.
So
Very true.
that's how a chemical engineer has to start through. And obviously, most of these companies recruit and they train you also. And if some people, want to straight away get into engineer design, they can get into the design. But normally, the kind of learning which you get in the design, there the problem is that you start designing the things about which you don't know anything. You have not seen it and you're
No,
doing it.
very true. Very
So
true.
normally you get them removed from the reality. And when you go to the field, ultimately where the production is happening, where the problem has to be solved, you'll not be able to visualize. And normally, like for example, let's say when I say that something is 1 meter diameter versus let's say 100 millimeters. Now, when I'm writing it on paper, it's very easy. You don't realize the significance. When you get into the field, then you realize, oh, this is what 1 meter looks like, or this is what 100 is like. And then you
Right,
realize
right.
that something like, for example, if you have to transport an equipment, how will you get it? I mean, those equipment have to travel from one place where it is manufactured to the place where it is being put up. So how the road situation will, how the logistics will work, how it will be manufactured. So all those things, start coming to you once you have gone through the field operations.
Wonderful, Shiv. I mean, I think you've given so much of food for thought that anyone who's listening to this will at least get a very clear picture of why it's important to get into operations first before anything else. That is the foundation. So, after you finish
Yeah.
your course, get into operations, get to understand what is happening on the ground in the plant. Only then can you understand everything else in future. Thank you for taking the time. It's been wonderful talking to you because I think your deep experience of decades comes through so wonderfully. And what I love is how you sketched out why it is important to spend that time. First, make up your mind that you want to be a chemical engineer and
Yeah.
then do the work necessary. So I'm sure this is going to be of great help to anyone who's looking to understand what the field of chemical engineering is like. Thank you for coming on the show. It's been a pleasure.
It's been indeed my pleasure that you invited me for this episode and this topic. And I always love to talk to the young people and try to make them understand what the real life is about, what the professional chemical engineers do. So I hope I would have contributed something to for people to know. And if I mean anything else needed, I'm always open to dialogues and chats.
Wonderful.
Thank you, Venu, for having me on this show. Thank you very much. Appreciate it.
Thank you, Shiv.
Thank you.
Thank you.
Thank you.
So, that was Shiv Shukla. I've had the pleasure of talking to him for almost an hour, and he gives a wonderful, foundation for how people can build their careers and where they can go, and what are the decisions that they need to make, and why it makes sense to get into operations first. Next week, another career journey, another wonderful exploration that we can look forward to. I'm very grateful to Shiv for having taken the time.